So vector additions, let's say we have two vectors, whether on space in R2 or in R3. So vector u plus vector v equals some vector w. We have two rules. Again, this is something that you are all well familiar with, but there is the triangle. Okay, yeah, sorry about that. We have the triangle rule, and we have the parallelogram rule, but they're really the same thing if you think about it. The rule said, at least graphically speaking, if we have vector u, let me say that this is vector u, something like that, and vector v, let me draw it here, vector v will make it look like this, a little bit shorter, okay? And we need to add these two together. So triangle rule tells you, take the first vector, let's say u, place it anywhere you want. Normally we're going to use the in any coordinate system, it doesn't matter. Take vector v and stick the initial point at the terminal point of u, the initial point of v at the terminal point of u, like so. So here's vector u, and here's vector v. The result of the addition will be a vector whose initial point is the initial point of u, and the terminal point is the terminal point of v. Okay? So the result is, this is vector w. And you can see that we created a triangle. All right? Similar rule, which, as I said, in my mind, it's identical. It's called the parallelogram rule. What is the difference between the two? Well, we create a parallelogram. Remember, we can move vectors and it still remain the same, right? So let's place vector u first, like so, and let's place vector v right here, so that they share the same initial point. And what we do, we draw another vector u parallel to the original vector, so that also will be u, and we close the parallelogram by drawing a vector v parallel to original vector v, and the diagonal, the same diagonal that we see here, well, this will be the result here on the parallelogram is simply the diagonal. Now, you need to be careful to connect from this endpoint, from the initial point to the terminal point. If you go with the other diagonal, you actually perform subtraction. Okay? One thing, if you go back to your trigonometry, a lot of time, if we know the magnitude of u and v and we know the angle, then we can use the law of cosine to come up with the sum. So the law of cosine in trig will come handy. Okay. So the next exercise, shall I give you two vectors and we'll try to draw the... let's go and do subtraction. I'm debating whether to have a little example, draw the sum of two vectors, but we'll see. Subtractions are similar to what we had before. Vector u minus vector v give you a vector w, like so. And but the way to do it, we can write subtraction is addition of opposite. So subtraction equal addition of the opposite vector. What do I mean by that? Instead of u minus v, since we have a rule for addition, we can say u minus v equals u plus negative v. So what is negative v? we just flip initial and terminal points. Okay. For example, if we go with the same uv that we had before, then if u is this vector, right? V is this vector, then negative V will be this vector. So if we do u minus V, then we'll go, if we use the triangle rule, for instance, we'll go u, oops, this is not exactly, well, close enough, I guess. I can do a better job. So this is u, and instead of adding V, as we did before, like so, I'm going to add negative V, which is this one. Okay? So let me write, this is vector u, and this is vector negative V. And you simply add these two together, applying the same rule, initial point of u connected to terminal point of V, of negative V. Okay? So this result, W, is u minus V. Guys, tell me, anybody here feel that I need to give you an example sketching?
Wouldn't you put the W the opposite way, like negative, right?
You always, the result always going to be initial to terminal. Initial refers to terminal of the second, if you use the triangle rule. Okay? This will be the same thing when we do the parallelogram. Let's talk about scalar multiplication. This is really redundant because you all saw this already either in trig or pre-calculus, so this is simply a little refresher. Scalar multiplication. Scalar multiplication is the word scalar comes from scale. We take a vector and we scale it. For instance, if we start with an initial vector that has a certain magnitude, let's say a unit, 3 units, and we multiply it by a constant, let's say c, and c equals 5, then now the new scale vector will be 5 times 3, 15. That would be the magnitude. So, so we're going to write c times vector v is a vector v with a magnitude scaled by a factor of c. C equal a constant. Okay, so for example, if the magnitude of vector A is 3, then 5 times A, or the magnitude of 5 times A has a magnitude. Let's write it here. The vector of 5A has a magnitude okay. So this is how it works. And of course, we already know that negative, if we apply negative, the opposite vector, negative v, we can write it as negative 1 times v is the opposite of v. Okay? And this is true for regardless of dimension. So this was a quick refresher.